Continuous probability density functions is what we are going to see in this lesson. It's a new topic. Please don't forget to subscribe to the channel. Now, this one we have seen in the last lesson when we are covering this script. We have seen how we define a PDF. A PDF in simple terms is a function that allocates probability to given values of x. We said if it's discrete, it allocates it to specific values of x. But now in continuous, if the PDF is f of x, now for it allocates probabilities to a given range of values of x. That's the difference. The other one for discrete, it specifically specifies the probability to each value of x. But this one, it specifies for a range of values of x. So, if it has a continuous domain, here the domain is continuous. So the probability can be from A to B. So that's why you said the range is continuous. You can't count that domain because there are many values of x there. So the f of x is continuous random variables, allocates probabilities to all values in a certain interval that x can take. Consider PDF f of x continuous on a domain from A to B, and x is in the interval, xi is in the interval. This means xi is in the interval A to B. So xi is in this interval. So if we give it that this is our f of x and this is our area text from A to B. Now, for continuous random variable, always the probability is non-negative, the first. So this f of x is always non-negative. It means that it starts from 0, goes up. If this is the interval, then when we interpret the area under this f of x from A to B, and if this A to B is the interval that this f of x takes, then it means that the whole, when we interpret all the probabilities, we get 1. So that's the idea there. Then if we have A, when x is in the interval of xi, it means that now we interpret now from the lower limit up to the upper limit, which is here. But we say this xi should be between A and B. So that's the idea. When we have x is equal to b, now we start with this one as our lower limit will be there. And so that's how we shall get the probability on this range there. Let us see some examples there. Continuous is also very easy. Nothing hard you are going to find in this topic. So a continuous random variable has a PDF. This is now the PDF. This means that, so for values from 0 to 4, they will take on this probability. All of them will be having, their probabilities will be defined by this function. Now, here in continuous, signs we take them to be the same, so they are not so important here, signs. But in discrete, signs are very important. But here, we don't take them. So this means that 0 elsewhere means that for any value of x which is not in this range, its probability is 0. That's why they mean with 0 elsewhere. So this means that this probability is here for this function from 0 to 4. If it's beyond 4 or less than 0, then it's 0. Simple terms. Find the value of the constant k, b, find this, then find that. So to get the value of constant k, all we need to know that when I interpret this PDF, all this probability from 0 to 1, I should be getting a unit. So to handle this, now my solution, but A, all I know that when I sum from A to B of f of x dx, so all values of x, I should get a 1. Now it means that now from here, our f of x is this. So our f of x was given here as kx on the interval now from 0 to 4. So meaning I'll be having now from 0 to 4. Now my f of x is here, kx. Now x is equal to 1. So I think we know how to integrate. So we are going to integrate this. We said it can easily pull out the constant. So this will be now k. When we integrate x, we get x squared over 2. Then from 0 to 4 equaling to 1. Now there, substituting the upper limit minus the lower limit. So this will be evaluated at these limits. When I put here 4, then minus, I put in the lower limit. All of this is 1. So start what I'm going to be having, this is 0, 16 divided by that's 8. So I have 8k equaling to 1. And so my k is 1 over 8. So I have my value of k. Mean that now here my function, if I come and substitute here, so that my f of x now will be x over 8. When I substitute in the value of k here, we are putting that value of k in that function there. So now, meaning if I redefine this, now my f of x will be, after getting the value, get x over 8 at the interval. That's equal to 4, 0, else where. Now I'm redefining the function because I know the value of k. It's as simple as that. Now here, in part B, they want us to get the probability between 0 for x when it's between 0 and 2. Now it's that 0 and it is that A2 as the sense will be in this range. So it's 0 to 2, so somewhere means that now this will be integral from the lower to the upper now of f of x dx. Now we have this, so we have now 0 to 2, our f of x is here, so it's there, which is x over 8, now dx. And if I integrate this, then you increase the power by 1, we divide by any power. So I'll be adding x squared over 16. Remember, I'm going to be adding divided by 2 by 2 times 8, that will be the 16. Now from 0 to 2. Now you see, when I put in those limits, I have 2 squared over 16 minus 0 squared over 16. And the answer here I'm getting, this will be 4 over that. It will be after that. Now my probability to is after it is. So now when I come to part C, the one with the probability, now from 0 to a 3. You want me to get from 0 to 3. From 0, here the sign is saying they mean the same. So it will be from 0 to now 3, f of x dx, which will be integral from 0 to 3. Now our f of x is x over 8 dx, which will be x cubed, make x squared over 16 from 0 to 3. Then you put in the upper limit, you have 8 over 3, because you are going to say, is it 8? No, it's not 8. It's not 8. When you put in a 2, we have now 9. When you put in 3 square, you have 9 over 16, then minus 0, which will give us 9 over 16 probability. So, remember, that's how we handle the basics. Now we are going to see more examples about these continuous random variables. See you there.